So as I said in the previous video, domain and range is just simply knowing that domain is going to be your x values or your input values, and range is your output or your y values. So if we're looking at example number 1, if it asks for the domain and it gives us the list of input and output values, we know that the domain is going to be -3, +1, and 4. That's all there is to it, and I'll put them in those fancy brackets. I'm sure they're called something else. But the range then will be 3, -2, 1, and 4. That's all you guys are doing, just identifying what are your input values, what are your output values. There's, again, different representations. You can do it you can identify it if they're giving you a diagram, if they're giving you a graph, if they give you an equation. But if they give you a list, it's just a matter of listing out each set. So if we look at number 3, the domain and range, it gives you ordered pairs. So remember that in ordered pairs, the first value is your x, the second value is your y. So the domain values will be -4, 1, and 3. I just listed them in order from least to greatest. I'm not picky about it. And you don't need to list one twice. If it is there twice, it's fine, but you don't have to list it twice. And then your range values will be -4, -2, and 2. So that's all that there is to it. So go ahead and try those couple of examples that I didn't do, and I'm just going to keep on moving along here. So for example 5 and 6, they give you a graph and then ask you to find the domain and range. So we're going to find intervals. Now remember, interval notation is with the parentheses or the brackets. So if we're looking at the domain, remember those are your x values, and domain is left to right. Remember, we look at a graph like we read a book. We go from left to right. So if there are not arrows here, they actually give us starting and stopping points. The first input value is here at -8. It is included because it's filled in, and then it stops here at +7. So because that dot is not closed in, it should not be included in your domain. It's everything up to 7. So essentially 6.9 repeated forever. So we're going to go to 7 but not included. So we'll do parentheses. And then the range is from bottom to top. So the lowest y value is there at 5, and the highest y value stops at 6. So this dot is included. This point is on your graph, part of your function, so it's included. So both values can use a bracket. So -5 to +6. All of these y values are on your graph, so they do need to be included. So if we look at number 6, I'm just going to draw arrows because this graph would continue off of our calculator if we had a screen that infinitely went forever, which we don't have. But so if you're looking at the domain and range, left to right, this graph is really going to continue on forever in that left direction. In the same way in the right direction. Is it gradual? Yes. And is it more down than left or right? Yes. But it is still going left and right forever. So in this case, your domain will be negative to positive infinity. The range from bottom to top is going to continue on forever, but the highest point that it ever reaches is there at 2. So we can't ever reach negative infinity. So that is technically our starting point or our lowest point that our graph reaches. But the highest point it's going to reach is 2, which is part of our function. So we're going to use a bracket. So remember, parentheses not included, brackets is included. So for numbers 7 through 13, I did write up there that it would probably benefit you guys to graph them, so you'll need your graphing calculator. Since you guys don't know what they look like, they're all different types of functions, so we haven't learned all functions yet. So if you could just type them into your calculator, then you can see what they look like. So for number 7, it's an absolute value equation. So I zoomed in on my graph, so it's the coordinates are a little funky, but you can see for the most part where they intersect. So my point for my absolute value, the lowest point is right here at -3, -2, and then it continues upward into infinity. So if you're looking at domain, left and right, there's no restrictions. It does continue forever in the left and right direction. So that would be -2, positive infinity. Now range, from the lowest point to the highest point, the lowest point it's ever reaching is that -3, which is part of our function, and then it continues up to positive infinity. Excuse me. So that would be it. So for number 8, my graph would continue on, so it sort of goes down like this, continues down. There's no point in any direction, left, right, up, down, where it's stopping. So, like I said, it's gradual, but it does continue in both directions, horizontally, left and right. So it will be negative to positive for your domain. And the range, it's a little easier to see that there's no point where it stops there either. It continues towards negative infinity, it continues up towards positive infinity, never stopping. So that would actually be the same for my range as well. The last one I'm going to do with you guys is number 11, and that is the function y equals the square root of x plus 4 plus 6. So I graphed it on my calculator, and be careful when you guys are putting this in that square root should only be over the x plus 4. The plus 6 should be separate and not underneath that radical when you guys are typing it in the y equals equation of your calculator. So if we're looking at this function, we'll learn this as we get further into this unit, but that plus 4 moves it left 4, and the plus 6 moves it up 6. So this point on my graph that then goes up forever, the point where it starts is -4, positive 6. So the domain from left to right, the furthest left that my graph goes is that -4, which is part of the graph, and then goes forever in the right horizontal direction towards positive infinity. So the range, the lowest point that function ever reaches is positive 6, which is part of my function or my graph, so it will get brackets, and it goes forever up towards positive infinity. It's gradual, but it does go up. It looks like it's really going just right, but it is slowly rising higher and higher. So it will go towards positive infinity in the vertical direction. So that's it. So that's why I think it's helpful to graph these when you guys are trying to find the domain range, because it's easier if you have a visual, because you haven't learned all of these functions yet. So go ahead and try the couple that remain that I have not done with you guys, and if you want me to check them, I can.